Oh, one more thing. If you have questions, we're going to do a Q&A at the end. So please send me your questions in a private chat to me directly. And when we're done with that, we'll roll into kind of a free form social time and we can all chat amongst ourselves, or we can even have questions then. So please do send me questions in the chat. And with that, I'll let them take it away.
Right, thanks, Mike. So hi, everyone. Thank you for attending our session. My name is Glennis, and I'm very happy to be here today along with my team. Huge thanks to ISSA and Mike for inviting us here today. So today's topic will be on hacking humans with AI as a service. This sharing consists of our research that was presented in Black Hat US and DEF CON earlier this year. So let me just introduce to you guys our team. We are part of a research team of 4 from Singapore. We work at the GovTech, Government Technology Agencies, Cybersecurity Group, or GovTech CSG for short. So this research is led by Eugene, also known as Space Raccoon-Sec in the cybersecurity community. Kyo and myself are part of the red team in GovTech, and we lead the phishing exercises for this research. And finally, we have Timothy, who lead the technical defense research against AI-generated text. So here's what we'll cover today, starting with an introduction of human hacking. We'll also explain some challenges faced when conducting social engineering exercises. Next, we'll look at the recent advances in AI and how the challenges faced in phishing could be better addressed with AI as a service. And then we will look into the viability of human hacking using AI as a service. And finally, we'll look into the defenses against AI phishing, such as automated AI detection, before summing up some key takeaways from our presentation. So feel free to drop us questions along the way as well, like Matt has mentioned just now. So first up, let's look at social engineering. So social engineering is the psychological manipulation of people into performing actions they usually may not. Here are 3 common influencing tactics, such as authority, creating a sense of urgency, and providing context-specific information to lower people's guard. So all of these aims to exploit our blind spots and break security chains. Even after going through training programs or security awareness trainings, it is noted that almost 20% of the employees are still falling prey to simulated phishing links. The rate increased to 43% in a study on spear phishing email against more general users. So as compared to systems, technology, and other security controls, humans, I guess, are often deemed as the weakest link in the security chains. So this is why we'll be looking at the delivery of phishing emails today. While phishing email used to be pretty obvious with like jarring fonts, huge fonts, or like the famous Nigerian prince pretext, we'll see how things may be changing with AI as a service. Here is a typical manual phishing workflow for a red team operations. Like for example, in a simulated phishing exercise, the operator would typically start with intelligence gathering of the targets. So this is also known as OSINT. So they want to understand more about the targets, what are some of the posts he or she may be interested in, and jobs that he's looking at. So things like their social media presence, this could be done either manually or with the help of automated tools. With an understanding of the targets, the operators then worked on crafting a suitable phishing email. So this usually takes the amount of time that's required for this context generation varies depending on each target. But all in all, we could see that even though phishing often yield good results, be it for red team engineers or simulation exercises, it often takes significant time to research or like just focus in on the target and effort to analyze all these results. So these efforts kind of increase with each new target. So imagine if there's like tens of targets and then against hundreds of targets. So this would increase quite a lot. These challenges, we broadly categorize them as behavioral analysis and text generation. So interestingly, these are also strengths of AI, right? So capabilities of AI have improved over the past few years, and we have a greater understanding of what AI can do and cannot do. For that, here are some of the tools that were used by recruiters to automatically analyze public information such as LinkedIn profiles. So all these are AI as a service. So coming from an attacker's perspective or as a red team operator, we could repurpose it to perform personality analysis. Although these results could only provide a general direction, I guess it forms a good foundation for the engineers to work on. after collecting information, it is time for text generation. Right. So June last year, OpenAI released a text in, text out interface for assessing the state-of-the-art language model GPT-3. Having an API for GPT-3 model provides a major leap in accessibility. It used to take a really long compute time and millions of dollars to train these models individually, but users could now access it via the API for just a few cents per thousand tokens. So essentially, it became accessible to a lot of other people, a lot of people that previously did not have the capability or resources to train such a model. So GPT-3 has, OpenAI has quite a lot of language model for them just for GPT-3. Here are some of the examples that are found. As a simple example of how it works, we could input the following instruction on our right-hand side. So explain quantum physics to a 6-year-old, and here's what the API returned to that instruction. Right? So it kind of became interesting what happens with OpenAI. What happens if we instruct OpenAI to write emails instead? So with this just few sentences that are bolded on top, we instruct the model to create an email that encourage the targets to open and attach document. All right, note that OpenAI actually writes a nice email format as well with dear Mr. So and content as follow. So this become very interesting and also quite amazing for OpenAI to be able to achieve such a feat. So with greater context and detailed instructions, we can see that the model may generate coherent email content for the considerations of the red team operators. So within just a few seconds, we have selections of phishing contents that are available. OpenAI also provides parameters to vary the generated content. So like, for example, with the same prompt, a different set of output can be obtained. This can be varied based on the parameter known as temperature. And just with the same prompt, we have a different set of output. This is the process of pretext creation and generation. So we have seen bits and pieces of how AI as a service may help in phishing campaigns for victim operations. Let's now put it all together to see how it might work. It could work. Right? So here's the diagram of the revised phishing workflow as compared to earlier on, after we have applied various AI services during the different stages of the phishing campaign. So first up, instead of manually reviewing the OSINT data source like LinkedIn posts, Twitter profile, or their blog posts, we'll feed this open source information into Semantics AI, which will perform personality analysis on the targets. So the original purpose of Semantics AI is to produce a personality report and generate communications advice for HR or recruiters. Here's just an example of the JSON output from Semantics AI. This is just an example that there are actually many other personality analysis services available in the market. With the JSON output that we have just now, we'll pass it to a simple plain text instruction and eventually feed it to OpenAI's GPT-3 model. So essentially, the plain text instructions describe to the model about the targets and how to better approach them. So, things like in this example, we are simply asking the model to craft an email to convince the target to join the company. So we also ask the model to be formal and objective with the information from Semantics AI. Finally, here we have the example output from OpenAI's GPT-3. This can serve as a base for future more edits, for example, like replacing the entities to relevant names, subject titles. We may also want to add in phishing links or a QR code to enhance the email content. But more importantly, we see that the analysis and content generation is largely addressed by AI as a service. So what's left is to launch the phishing targets, the phishing campaigns to our target. So as part of our research, we also conducted some experiments to see whether phishing content generated by AI remains convincing to targets. So over the course of 3 months, we conducted 2 types of experiments with over 200 targets across multiple authorized phishing exercises. For the experiment, we used a custom phishing tracking system, but just to note that the API interface of AI as a service meant that we could easily integrate it to existing tools, such as like Goldfish open source phishing framework. So there are two types of experiments that we conducted. The first type of experiment, which we call type 1, is designed to investigate the effectiveness of convincing targets to click on the phishing link in the email. And then as compared to the second type of experiment, which we call it as type 2, it is designed to investigate the effectiveness of convincing targets to open the malicious attachment in the email instead. Here's the example, or here's the experiment set up for type 1. There are two stages. Stage 1 is a mass phishing exercise to identify targets who are susceptible to phishing. Stage 2 instead is the spear phishing exercise to harvest credentials from the targets identified from stage 1. So essentially, those who fall prey in stage 1 will receive stage 2 spear phishing email. For type 1 experiments, each target will receive both email, one that will be generated by the AI, while the other that's generated by a human or the red team operator. Right. So the table on the right is the sample size for each phishing exercises conducted using the type 1 experiment setup. Notice that there are some rows under the human column that are empty views, especially for those in stage 2. This is because there are no victims that fell prey to in stage 1 for the contents generated by humans, hence they did not proceed with the stage 2 spear phishing email content. All right, so here's the results. For each stage, we collect a few key metrics. Firstly, we measure the percentage of targets that clicked on the phishing link. So this can be seen in the bar chart on top. Each pair represents the set of AI versus human results. In exercise A, we see that 20% of the targets clicked on the phishing link from the content generated by AI, while none fall prey to the content generated by humans. Next, we see that from the victims that clicked on the link in experiment A, in the pie chart below, we measure the interaction and the percentage of victims that further interacted with the phishing site. So from that 20%, 80% of them further interacted with the phishing site and submitted information. So while AI outperformed human counterparts in exercise A more prominently and also in exercise C, we see that the middle one, exercise B, tells a slightly different story. All right, so humans scored a slightly better phishing rate, which in terms of percentage, but in terms of numbers, it translates to just one more victims than the AI generated content. Right. So stage 2 is where spear phishing is done on the stage 1 victims. A personalized email content is sent in stage 2. So each of them receives a personalized email. We see considerable success in convincing the targets to click on the phishing link, and 33% of them attempted to submit their credentials as well. So experiment B results was pretty interesting because in stage 1, we see that the human generated content outperformed those in AI, but in stage 2, it is the reverse. AI instead outperformed the humans instead. So unfortunately for experiment C, our last experiment, the phishing site was flagged by most browsers as deceptive. So the stats and the experiment was put to a stop. So that's for type 1. And we'll now look at type 2 experiments. The type 2 experiments, right, the target group is divided into two subgroups instead. So one subgroup will receive the AI generated phishing content, while the other subgroup will receive the phishing content generated manually by the human. So the results as seen on our right hand side, it shows that the AI generated content convinced more targets to open the malicious document instead. Great. So here are some of our key observations from the experiments. Firstly, using AI as a service helped to reduce the time required for phishing content curation and context analysis. So this frees up more resources for the human operators or for the red team operators to focus on their other tasks. So the second thing that we noted that was the AI generated phishing content was largely more convincing as compared to the ones generated by humans. While there may be other variables at work, it is an indication that AI does have quite a lot of potential in innovating red team operations or writing phishing email contents, for example. So lastly, we observe that there is a varying degree of governance relating to the access of AI services in the market. So for example, during our research, some of the AI services can be accessed by simply registering for a trial account with your email address. So on the other hand, there are services like OpenAI that were certainly way more strict in terms of their usage because they validate use cases by the individuals when they attempt to register for an account. So having demonstrated the viability of an AI phishing pipeline, we decided to explore potential defenses against it. So this is important as access to AI as a service grows over time. Naturally, the first thing that comes to our mind is to detect synthetic text. However, detecting synthetic text remains a hard problem to solve. But generally, here are three common ways that we found to tackle this issue. Simple classifier, where we define certain rules based on text. The second one is fine-tuning based detection, where we train a new model based on inputs from different kinds of language model, from GPT-3, GPT-2, and so on. And then the last one is the zero-shot detection, where the model learns a classifier on one set of labels and then evaluates on a different set of label that the classifier had never seen before. So we eventually decided on the zero-shot approach as it gives us more flexibility so that we'll be able to use it to predict other sets of language models as well. As part of this, we also looked into the GLTR project for more insights. Based on their white paper, the three main tests to detect synthetic text are as follows. So the first one is to look at the probability of the word given the previous words in sequence. The second one is the absolute rank of a word, and finally the entropy of the predicted distribution. While deciding on the approach of detecting synthetic text by GPT-3, one of the major challenges that we faced was that we do not have direct access to the model. So without direct access, we are limited in the parameters that we are able to control. We are also limited in the data set that is returned from the generated text, such as the top 100 log prop for our choices of words. So eventually in our test, we compared the matrix of 4 categories, GPT-3, GPT-2, and GPT-2 Tune, and finally the human samples. So here's an example of the matrices. Our GPT-2 Tune model is based on an email corpus that our team has collected. We found that humans generally use more random words that are out of the top 100 predictions from the GPT-3 model. So that became a point to look into. So why not let's put our test, let's put test to our proof of concept GPT-3 detection tool. All right, so in this slide, we have 3 email samples. Only one of them is crafted manually by a human by hand, while the other 2 is generated by OpenAI using their AI service. So we'll just take a short activity here. Shall we take a guess on which one was generated by AI and which one generated by humans? Right, so just leave it in the chat. We'll just have a quick activity for this. Great. So here we have sample A, sample B, and sample C. Looking at all this information, don't worry if it appears a bit similar. Even for our team, we have some difficulties in looking into this. So I guess this is also where the point of how convincing phishing emails generated by AI service could. We have because it is just interesting. Key things to look out for in phishing emails. All right, so I'll continue on with the examples as follow. No worries, the email content will still be available in the subsequent slides. All right, so let's look at sample A first. So sample A is actually generated by AI, and here's the visual output from the tool. We see that the ratio between the probabilities of the top predicted words and the following word is at 0.833. So this is actually a sample that is generated by the AI. All right, so then similarly, sample B is an AI generated content. We see that the probability here, the ratio here is 0.884. And finally, for sample C, the ratio is at 0.554. So this, the relatively lower ratio is an indication that this is a human-generated context, which in this case is true. All right, so sample A and B is generated by AI, and eventually sample C is generated by humans. So apart from our technical defenses, we also briefly explored the model AI governance framework released by Singapore as a useful reference to address key ethical and governance issues when deploying AI solutions. So here are some of the key recommendations provided from them. Using implementation and self-assessment guide for organizations, policies for explanations, and having a good, clear roles and responsibilities for the ethical deployment of AI. So specifically for consumers, it's advised to adopt the human in the loop approach for AI augmented decision making. And for suppliers or for service providers, it is key to ensure that the usage is traceable and auditable, and to enforce acceptable use policies instead, in case some of the services are misused by malicious actors. All right, quickly, we are now looking at some of the key takeaways before we open up for the Q&A with the team. We summarize 3 key points as follows from our presentation. So the first thing is that the rapid growth of AI as a service has placed advanced, cost-effective text generation capabilities in the hands of the global market. So this means that it could be used by both authorized and malicious phishing campaigns. In that case, while automated tools can be used to build defenses against AI-generated text, current approaches are brittle and model dependent. So in that case, AI-assisted human detection of the generated text could be more effective. And then finally, decision makers also have the responsibility to implement sound strategies governing the usage of advanced AI as a service. So tightening the usage of advanced AI as a service could potentially reduce the likelihood of the abuse. All right. So we have quickly reached the end of our sharing, and we hope that there are some key takeaways for you from our work. So right. So I guess we'll open up for Q&A now. Feel free to let us know if there's any questions, and the team is here to answer them as well.
Great, thank you, Gladys. That was great. So there's a number of things that come up. Actually came up the last time I heard you speak, and I didn't get a chance to ask then. But one of the things that I always think of when I think in terms of phishing campaigns and AI as a defense, both and as an attack, is natural language processing and natural language understanding. And my understanding is there's now a number of companies out there, security companies, that have technologies that use AI and ML to effectively read the email that could be a phishing campaign, and they're able to tell whether it's actually from not only human or not human, but from a specific human or not. Could you speak a little bit about your understanding of natural language understanding and natural language processing as per both from the attacker and the defender side of how people will use this to both defend and potentially attack?
Okay, so maybe I'll take the first question first, and my team will just add on along the way. So I guess when for the attacker side, when we send the phishing email contents, in the case of whether it is ML or whether it's generated by AI as a service, eventually what the victims see is just the email content. And apart from just the email content, there are also other key things that they could look out for. So whether the email source came from a reputable one, whether it came from an internet sources. So in this case, all these are sort of out of control for not just the email filters, but also in the case of whether it's AI generated or not. So in that case, these are things that they could look out for. And in case of the defenses part, so like we have seen in this in our work previously, detecting AI generated text remains kind of a problem, and it's also very model dependent, right? So in the case of like in ML or so if the model is independently trained by the attackers or the users specific things that are out of the matrix they are looking out for, this could present a slight problem for the defender side as well. So this is just some of my thoughts because I mainly came from the attacker's point of view. So if there's anyone in the team that would like to add on to that, feel free to. If not, we could leave it in the chat as well.
Yeah, thanks, Glennis. I hope everyone can hear me. So I'm just helping to explain a bit more on the technical defense. I think that's a great question raised by Mike. So during our research, we find that it's quite a challenge to see if we can actually detect human-generated or AI-generated text. So even for most of the NLP libraries out there, the detection really relies heavily on the model that was being used to generate the text. So that's why we are saying that it's quite model. The detection is quite brittle in a sense where it is reliant on the model itself. So for example, you're using GPT-2 to generate the text, and your detector is based on GPT-3. The accuracy is not very good. So this is what we actually observe, and so this makes it hard in terms of the defense, because from it goes back to the same principle, right? Attacker just need to find that one model or just one point, and defender has to defend against all models and at all points. So this is why we see that as a challenge, but we also see that as a potential area of innovation, depending on whether there are new techniques being discovered to detect text. But I think so far, based on research, I think GLTR has been the more practical and actually the more fruitful approach that we thought that can be used in the industry setting. Yeah, so I think that's my take on that.